Now we're going to talk about composite functions, so composition of two functions. So we've got f of g of x. So this is how we're going to say this out loud, f of g of x. This is the notation that we're going to use. There's this little kind of open circle in between f and g. So we read that as f of g of x. Equivalently, we could write this as f of, and then put g of x inside the parentheses. And also a shorthand for this, I could just say find f of g. So these are all equivalent, and we read these out as f of g of x, or just f of g. All right, so what on earth is this monstrosity? What we're going to do, it's kind of like the difference quotient thing. If you guys remember when we were evaluating f of x plus h as part of the difference quotient, and we would plug that expression x plus h in, now we're going to be plugging in whatever expression is equal to our g of x function. So in this case, we have our f of x function, which is f of x equals negative 3x minus 8, and we have g of x equals x minus 5. And we're asked to find f of g of x. So in other words, we want to find f of g of x. So we're plugging g of x into the f function. G of x is the same thing as x minus 5. So this is going to be f of x minus 5. And looking at the instructions we get from our f function, whatever we put inside the parentheses, in this case we have f of x, we're going to take negative 3 times x, whatever's in parentheses, and then subtract 8. Now we're going to take negative 3 times x minus 5, because that's what's in parentheses now, and then subtract 8. So we have negative 3x distributing. Negative 3 times negative 5 is plus 15, and then we have our minus 8. So we get a grand total of negative 3x plus 7. So our composition, f of g, is equal to negative 3x plus 7. That's our composition function. Okay, and again, just to kind of go back and review what just happened, we want to find f of g of x. So we're plugging g of x into the f function. G of x is the same thing as x minus 5, right? G of x equals x minus 5. So that's how I know what to put in there. And using the instructions from my f function, I know I'm going to take negative 3, multiply it by x, and then subtract 8. Now I'm going to take negative 3, multiply it by x minus 5, and subtract 8. So instead of x being the input to the function, now the g of x function is the input. And g of x is the same thing as x minus 5, so that's why I'm plugging x minus 5 into that bigger function. So kind of crazy looking. All right, let's go the other direction. Now we want to find g of f of x. So I could also write this as just g of f. G of f of x, we could write that as g, and then in parentheses, f of x. And we read this out loud as g of f of x. Okay, so using the same two functions, f of x equals negative 3x minus 8, g of x equals x minus 5, we want to find the other composition, g of f of x. So we're using the g of x function as our starting point. G of f of x is the same thing as g of negative 3x minus 8. And using my instructions from up here, whatever is inside the parentheses, I'm going to take that and subtract 5. So I'm going to take my negative 3x minus 8, and then I'm going to subtract 5. So this gives me a grand total of negative 3x and then negative 13, adding the negative 8 and negative 5. So g of f equals negative 3x minus 13. All right, so again, just to recap what just happened, g of f of x, I'm plugging f of x into the g function. F of x is the same thing as negative 3x minus 8, so that's what I'm plugging into my g function. And my instructions for my g of x function say to take x minus 5 Now I'm taking negative 3x minus 8 minus 5, because that's what my f of x function is. Okay, and I also want to just mention, when I look at these, I would call my g function the outer function, and I call f of x that inner function. Up here, f would be the outer function, g of x is the inner function. So a lot of times that's how I refer to these. So if I ever say the inner function, I mean that input, that guy that's going inside the parentheses. All right, so for number 11, it says find f of g of x, and then we've got f of x equals 5x plus 9 over x plus 4, g of x equals x plus 1. So f is going to act as my outer function, and then I'm going to put inside my g of x. So make sure you keep that order. Whichever one appears first is your outer function, whichever one appears second is your inner function. So this means I'm going to have f, and then I'm going to put inside f my x plus 1. So this means in my f function, whatever was happening to x before, I'm going to replace that with x plus 1 in parentheses. So wherever there was an x before, I'm going to replace that with x plus 1 in parentheses. And simplifying this gives me 5x plus 5, and then plus 9 up in the numerator. X plus 1 plus 4 gives me x plus 5. This gives me a grand total of 5x plus 14 over x plus 5. So my f of g function is 5x plus 14 over x plus 5. Okay. Now number 12, find g of f of x when f of x equals x plus 4 and g of x equals x squared minus 3. So now g is going to be my outer function. I'm finding g of f of x, which is g of x plus 4. And now I'm going to take the instructions for my g function. Instead of x squared, I'm going to have x plus 4 squared. So inside the parentheses there, I'm going to put x plus 4 and square it, then subtract 3. And notice that this is going to be a FOIL process. I'm going to multiply x plus 4 times x plus 4. So x plus 4 times x plus 4, and then minus 3. So this will be x squared plus 4x plus 4x plus 16, and then minus 3. And combining like terms, that gives me x squared plus 8x, and then 16 minus 3 is plus 13. So that's my g of f function. All right, so a little more practice with this. Now we're given f of x equals 3x minus 1, g of x equals x minus 5. So g of f of x equals g of 3x minus 1 equals 3x minus 1 and then minus 5. So that would just be 3x minus 6. That's my g of f function. F of f, so now I'm plugging a function into itself. F of 3x minus 1 equals 3 times 3x minus 1 and then minus 1. So I'm putting a function inside itself. And distributing, this gives me 9x minus 3 minus 1 for a grand total of 9x minus 4. So that would be my f of f function. All right, g of x. Now I have g of x, which is g of x minus 5, So I'm going to take x minus 5 and subtract 5 from that, which gives me x minus 10. So that would be my g of g function. All right, and finally, I have g of f of negative 5. So there are two ways to find this, similar to when we were looking at our combinations. So method 1, I know from part A that g of f of x equals 3x minus 3x minus 6. So that's from part A up here. So I already found my g of f function. G of f of x is 3x minus 6. So g of f of negative 5 would equal 3 times negative 5 minus 6, which is negative 15 minus 6, which is negative 21. So that's method 1. Method 2, if I'm calculating g of f of negative 5, that's equivalent to g of f of negative 5. So first, I can evaluate f of negative 5. So f of negative 5, my f function is 3x minus 1, right? So I'm just going to show my work up here. F of negative 5 would be 3 times negative 5 minus 1, which gives me negative 15 minus 1. So that would be, negative 16. Negative 16. Okay, so f of negative 5 equals negative 16. Awesome. Now I'm going to rewrite this as g of negative 16. Right? G of f of negative 5 is the same thing as g of negative 16. And if I want to calculate g of negative 16, I can go back to my original function up here. G of negative 16 equals negative 16 minus 5, which equals negative 21. So I get negative 21 no matter how I evaluate it, right? So we'll talk more about domains on the next page, but I just want to point out that if f didn't exist where x equals negative 5, if we couldn't evaluate f of negative 5 for that inner function, we couldn't have evaluated the composition function at negative 5 either. So I just want to point out that that inner function is going to be really important when it comes to finding the domain for your composition function.